All revolutions have a waxing and waning period. A movement gains momentum, rises to a crescendo, and then loses steam. The scientific revolution, initiated during the European Renaissance, did not lose steam for a very long time. The flame was passed on from generation to generation.
It was a strange coincidence that Galileo was born the year Michelangelo died, and he died the year in which Newton was born. It was as if the torch of Renaissance was being transferred from one generation to the next without a break.
The person who really turned the tide against the Aristotelian concept of a geocentric universe in favor of the Copernican concept of a heliocentric one was Galileo Galilei. He used a combination of mathematics, logic, and brilliant observational techniques and laid the foundations of modern science.
Galileo is quite often regarded as the father of modern science. Now, the relationship and the synergy between experiment and theory that exists in science came out very clearly in his work. And he probably was the first person to design an experiment specifically to test a hypothesis, namely whether heavier bodies fell faster than the lighter ones. What is more, he was willing to modify or even reject that hypothesis on the basis of his findings. So this laid the foundation of what we now call the methods of science. I'd like to draw your attention to another aspect of Galileo's contribution. Latin was the language of science at that time. For example, Newton, who came after Galileo, wrote his Principia, or Principia if you like, in Latin and not in English. But Galileo chose to write two of his important books, the Dialogues and also another one, the Starry Messengers, in lucid Italian, so that even an ordinary person could follow the arguments. So he was not only working at the forefront of science, but also trying to communicate his ideas to ordinary people. Therefore, we can also call him the father of popular science.
Galileo realized that in order to defend Copernicus, he had to prove that the Earth could move without causing 1,000 inconveniences. The story goes that Galileo actually contradicted Aristotle by dropping balls of different weights from the Leaning Tower of Pisa.
That experiment was repeated later in a more complicated way. One had a coin and a feather in an evacuated chamber, and they were dropped, they fell together. Even on the surface of the moon, the astronauts repeated this feather and coin experiment. But we can demonstrate the same principle in a much simpler way. See, I have a heavy book and a light paper. And if I drop it from this height, obviously the book reaches the table before the paper. This comes very slowly. But how do I remove the resistance of the air? I can do it just by placing the paper on the book. Then the air is not able to ruffle the paper. And if I drop them together, you see they're falling together. If the acceleration of the paper was really less than that of the book, they would have fallen like this.
In the end, Galileo's zeal to popularize the Copernican system led to his downfall.
Now, a question is often asked, why was Copernicus not persecuted the way Galileo was? Opinions vary. Some say it's because Copernicus was already in deathbed when his book, Revolution of Heavenly Spheres, was published, and died even before people could realize the full impact, the full implication of his heliocentric model. Others opine that his was a purely theoretical exposition. Therefore, the church could afford to ignore it as a purely academic exercise which has nothing to do with reality. But Galileo's case was quite different. He had solid experimental evidence, the phases of Venus, the moons of Jupiter, which anyone else could verify. And not only that, he was very active in popularizing the heliocentric model by writing books in ordinary Italian and things like that. So that is why the church came down so heavily on him.
But now, in response to Galileo's relentless efforts to vindicate the Copernican model, the church banned De Revolutionibus. Johannes Kepler was furious at Galileo's lack of diplomacy. He complained, "Some, through their imprudent behavior, have brought things to such a point that the reading of the works of Copernicus, which remained absolutely free for years, is now prohibited."
We need not go into the details of the Galileo controversy. It's very well known anyway. But we would like to note one point here. That is, a formal permission was obtained from the Inquisition before the publication of the book Dialogues in 1632. But in spite of that, the very next year, that book, along with all other publications of Galileo, was banned by the church. Convicted of heresy, Galileo was put under house arrest for the rest of his life. Captivity, naturally, diminished his creative power to a great extent. A failing health and eventual blindness added to that. He lived for some 10 more years, and in that period, one major book that he wrote was Dialogues regarding new systems, new sciences. There he deals mostly with motion and the parabolic path of trajectories, parabolic trajectories of projectiles was given special attention in that book. But the Galileo story really doesn't end there. The ban on his books was lifted by Vatican almost 100 years after, in the 1730s. As recently as 1990s, the Vatican said that the Galileo episode was a tragic mistake. But soon after, the Pope said that the Galileo trial was fair. So it seems the Vatican is in two minds about Galileo.
Galileo died in the year 1642, the same year that Newton was born. His books were smuggled out of Italy and published in Holland and France. The spirit of freedom of scientific inquiry spread to Northern Europe. Open science as a practice became increasingly widespread in Europe during the late 16th and early 17th centuries. It represented a departure from the previously dominant practice of secrecy in the pursuit of nature's secrets. The patronage of the arts and sciences by the numerous princes had led to a highly asymmetric knowledge distribution. Discoveries were often kept a secret, and scientific knowledge remained confined to a small group of people. But with the emergence of new monarchies, the practice of science often became state endeavors. New academies of science were formed. The new academies made this knowledge accessible to the common people through publications and popular lectures. The emergence of this new practice of disclosure and demonstration led to cooperative rivalries in the dissemination of new knowledge. One scientist built upon the knowledge base created by another scientist and took it further. The scientific revolution thus gained momentum. The Accademia del Cimento in Florence, widely regarded as the first scientific institution in Europe, was founded in 1657. 100 years later, dozens of scientific societies were in operation across Europe. Many of these societies were publicly funded. The French Academy of Sciences was founded in 1666 by Louis XIV at the suggestion of Jean-Baptiste Colbert. Through this academy, France came to the forefront of scientific development in Europe in the 17th and 18th centuries. This academy also controlled French patent laws and acted as the liaison of artisans' knowledge to the public domain.
With the institutionalization of science, a number of changes took place. Academies of science came up in a number of countries. The Royal Academy in England, in France, and also in the eastern part of Europe, in Russia, for example. The members of these academies, scientists, their status grew inside the society. Fellow of the Royal Society or an academician of the Russian Academy of Science were highly respected. Not only that, these academics started bringing out journals, proceedings, where the working scientists would be publishing their papers and it will be disseminated among all other scientists.
Science is always a work in progress. When what scientists call law at a given time eventually breaks down, new opportunities for scientific progress usually appear. The Royal Society of London for the Improvement of Natural Knowledge, known simply as the Royal Society, was founded in 1660. It is the oldest such society still in existence. One of the earliest presidents of this society, Robert Boyle, began the practice of recording experiments in great detail so that others could replicate them. Something else happened in the year 1616. A young boy of 14, by the name Isaac Newton, was sent to the Trinity College at Cambridge to study mathematics. His family could not pay for his education, and he had to take up odd jobs to earn his tuition fees.
In the year 1665, an epidemic of plague broke down in parts of England, and the University of Cambridge was closed down. Newton, like many others, went back to his home and stayed there for the next 18 months or so. Now that forced vacation proved to be the most productive years of his entire scientific career. The next year, 1666, is often called the miracle year, annus mirabilis, of Newton's life. Because in that short period, he created the differential calculus, integral calculus, he stated and proved the binomial theorem, did experiments on optics, and what is more, he derived his inverse square law of gravitation sitting under an apple tree, as the story goes, thus laid the foundation of Newtonian physics. It can be said that the rest of his creative life was spent primarily in elaborating and consolidating the ideas that he gave birth to in those 18 months, in that miraculous year.
In 1665, Newton was elected a Fellow of the Royal Society of London. the Royal Society enjoyed the confidence and official support of the restored monarchy under King Charles II. The founding group of 12 natural philosophers decided to meet weekly to view experiments and discuss science. Robert Hooke was appointed the curator of experiments in 1662. His motto was Nullius in verba, or take nobody's word for it. Newton was, however, motivated by an inner urge to serve the cause of religion and philosophy. His method was akin to that of Galileo, but he took it much further.
One simple law of gravitation, which every school student of today studies and understands, could explain so many phenomena, from the fall of an apple, flight of a cannonball, movement of planets and satellites, and also occurrence of tides and eclipses. A law of this generality is unprecedented in the history of science.
Suddenly, the light of reason broke out and illuminated the whole universe as a gigantic system throughout which the same laws applied without exception.
The effect of Newton's mechanics was felt far beyond the boundaries of physics or natural philosophy, as it was called in those days, and it affected almost all other branches of science.
Newton's main interest was in the realm of mathematics and physics. But with equal energy and originality, he also plunged into chemistry, the early history of Western civilization, and theology. Among his special studies was an investigation based on biblical descriptions of the form and dimensions of Solomon's temple in Jerusalem. But he did not publish any of these findings. It was Robert Hooke who first motivated Newton to write about his findings on gravitation and planetary motion in his famous Principia.
From ancient times, the power of prophecy was looked upon as something superhuman, and people who possessed that power were not only admired but feared. After the advent of Newtonian mechanics, all of a sudden, the natural philosopher came to possess this supernatural power. For now, with sufficient accuracy, he can predict the movement of cannonballs, the movement of planets and moons, and also the exact timings of tides and eclipses. Not only that, he can even see invisible planets lying far beyond the visible ones. Slight deviation of the planet Uranus from its expected orbit suggested that there may be another planet beyond Uranus. Calculations pinpointed the position where that planet could be seen. Then very careful telescopic observations confirmed the existence of the planet Neptune. The story of Pluto is also similar. In 1682, a comet appeared which could be seen by all with naked eyes. Edmund Halley calculated and predicted that this comet would return after 76 years because it is moving in a closed orbit. It did, but Halley was not there to see it because he had died much earlier. So such was the power of Newtonian mechanics in predicting the future. In Newtonian mechanics, if the complete information about a particle, which includes its position, momentum and other relevant dynamical variables, and also the laws that are guiding the particle. So if the complete information about a particle at some instant of time is given, then his entire future and past can be calculated. Laplace took this a step further and said, if some super intelligence can know all the information about all the particles of the universe at some particular instant, then it would know the whole of future and the whole of past. Thus emerged the idea of a deterministic universe in which the past completely and uniquely determines the future. Free will has no role to play here. This model is also called mechanistic because this envisages the entire universe as a huge machine whose initial condition was fixed by somebody. We don't know who, could be God. So from that moment onward, it is completely governed by the natural laws. The success of Newtonian mechanics in explaining natural phenomena and also the success of the Industrial Revolution driven by machines in England and later in other parts of Europe consolidated and reinforced this mechanistic view of the universe. And this deterministic view reigned supreme till the beginning of the 20th century when quantum mechanics appeared on the scene.
After Hooke's death in 1703, Newton was elected the President of the Royal Society. He was knighted by Queen Anne in 1705. He spent his last years in London, but without ostentation, despite his status as a national hero. On 20th March 1727, Newton breathed his last at the ripe old age of 85. He was buried with great public ceremony at Westminster Abbey, the only English scientist to be ever honored this way. Alexander Pope, the famous English poet, wrote his epitaph in the following words. Nature and nature's laws lay hidden in night. God said, let Newton be, and all was light. Newton's laws held sway for 300 years.
Quantum mechanics was formulated in the early years of 20th century. Heisenberg showed that it is just not possible to measure the position and the momentum of a particle simultaneously with infinite accuracy. If one of them is measured with zero error, with absolute certainty, the other will become totally uncertain. So a practical compromise is to know or measure both these quantities, position and momentum, with some amount of uncertainty, some amount of error. But that doesn't fulfill the Newtonian criterion. So in this sense, determinism ceased to work in the quantum world.
When scientists observe regularities in natural phenomena, they encode their observations in what they term as natural laws. These reflect what science knows about nature at any given time. These laws allow us to predict cause and effect relationship. But these can fail when scientists try to use these to situations where their underlying assumptions do not apply. These are momentous phases from which new paradigms emerge.
One can have progress, but one can have reaction too. Same is true of history of science. In the following passage, which we are going to read out, Carl Sagan worries about the future of his country. that has much in common with our own worries. So allow me to read from Carl Sagan's last book, The Demon-Haunted World. Science is more than a body of knowledge. It's a way of thinking. I have a foreboding of an America in my children's and grandchildren's time when awesome technological powers are in the hands of a very few, and no one representing the public interest can even grasp the issue. When people have lost the ability to set their own agendas or knowledgeably question those in authority. When clutching our crystals and nervously consulting our horoscopes, our critical faculties in decline, unable to distinguish between what feels good and what is true, we slide, almost without noticing, into superstition and darkness.